Hey everyone, this lesson is on factoring using the GCF. So we're just starting our factoring process here. The first thing we need to talk about is the GCF, greatest common factor. The greatest common factor is the largest number that divides evenly into a set of numbers. For example, the GCF of 12 and 18 would be 6 because 6 is the largest number that divides evenly into both numbers. Right? 2 goes into both 12 and 18. That's a factor. It's a common factor. Well, so is 1 actually. 1 goes into both of them. 2 does. 3 goes into both 12 and 18. But 6 is the greatest common factor. So that's what we're looking for. What I'm going to do here is I'm going to give you kind of a procedure for finding that. If you can just see it in your head what the GCF is, that's fine. But this is kind of a procedure just to get the process down to find the GCF. Okay, so 36 and 60. What we're going to do first is find the prime factorizations of each number. So if you don't know the prime factorization, I have some other videos also on prime factorization, so make sure you look for that if you want to. Anyways, 36, you could do the tree to do that, 6 times 6, and then break down 6. 6 is 2 and 3 and 2 and 3. So 36 is 2 times 2 times 3 times 3. Okay, and 60, you could use 6 and 10. And then 6 is 2 times 3, and 10 is 2 times 5, so that's where the 2 times 2 times 3 times 5. Suppose we use a tree, so it's called prime factorization tree. Anyways, and then what we're going to do is we're going to circle what they have in common. What do they have in common? They have a 2 in common, another 2, and a 3. So there's a 2, and a 3. And then we're going to multiply that out, and that's our GCF, 2 times 2 times 3. Okay, so 12 is the largest number that goes into both 36 and 60. Now let's talk about variables. X to the third and x to the fifth. I'm going to give you a rule after we do this, but just be patient. We're going to talk about x to the third and what it means. Well, let's find the prime factorization. It's really not a number, it's a variable. X to the third means x times x times x. And x to the fifth means there's 5 of them, 5 x's. So what do they have in common? 3 x's, right? 1, 2, 3. So the GCF is x to the third. Well, looking at the original problem, one of them is x to the third and the other one is x to the fifth. So we actually write the variable with the lowest exponent. So whatever the variable is, we just write that variable with the lowest exponent. Okay, 84 and 120. If you can see what 84 and 120, what the GCF for those two numbers is, that's fine. It's kind of tough because they're large numbers. So you may decide to do the prime factorization. There's 84, and there's 120. Circle what they have in common. It looks like 12 again, right? Yeah, 12 goes to both 84 and 120. And then we're going to take the variable with the lowest exponent. So the exponents are 7 and 3. So the GCF is 12x to the third. Okay, now we're going to get into factoring. What we're doing is the reverse of the distributive property. We're going to use this statement, AB plus AC is equal to A times B plus C. We're going backwards. Here's our steps. Number 1, write the polynomial in descending order. Number 2, find the GCF of all terms of the polynomial. If the first term is negative, then the GCF is negative. So again, number 1, descending order, 2, GCF. Step 3, we're going to divide each term by the GCF. And then step 4 is we're going to put the GCF in front of parentheses, and the result of the division by the GCF, that's what's going to go inside the second parentheses. Right, I put that GCF in parentheses, but we're really not going to put that in parentheses. I just wanted to show it as that it's, to make clear that it's multiplication. Okay, here's our first problem. 18x plus 24. First step, is it in order? Yes, it's in order. Second step, GCF. What is a GCF for both terms? So for 18x and 24, what's the largest number that goes into 18 and 24? Yes, 6. And then do they have a variable in common? No, the 24 doesn't have a variable, so there's no common variable. So our GCF is just 6. Okay. Now we're going to divide each term by the GCF. So divide each of them by 6. That GCF is going to go in front of the parentheses, and the answer is going to go inside the parentheses. So 18x divided by 6 would be 3, and 24 divided by 6 would be 4. So here's our answer. 6, again in front of parentheses, and inside the parentheses would be 3x plus 4. Okay, negative 21x to the third plus 28x. Step 1 was to write it in descending order. Is it in descending order? Yes. The x to the third term goes first, and the x term goes second. So that's fine. Second step is to find the GCF. So for 21 and 28, what's our GCF? 7? And how about the variable? There's an x to the third and an x. So 7x, right? The lowest exponent. And since the first term is negative, then the GCF is negative. So our GCF is negative 7x. Divide each term by the GCF. (21) divided by 7 would be 3. And there's 3 x's on top, 1 on the bottom, so that'll be x squared. It's going to be positive because there's 2 negatives. The second term will be negative because it's a positive and a negative, and the x's cancel. So negative 7x times 3x squared minus 4. Right, factor 24x minus 15x squared plus 33. What's our first step? Right, put it in order. It's not in order, right? It's got to be the highest degree term to the lowest degree term. Now our GCF. What number goes into 15, 24, and 33? That's right, 3. And do they have a variable in common? No, right? The first term is x squared, the second term is x, the last term does not have an x, so there's no common variable. So the GCF is 3, almost, -3, right? Because the first term is negative. So our GCF is -3. Now we're going to divide each term by the GCF. The result will be written inside the parentheses, the -3 in front of the parentheses. So the -3 is in front of the parentheses, 5x squared minus 8x minus 11 inside the parentheses. All right, this example has two variables. It's actually already in descending order. The degree of the first term is 9. The degree of the second term is 7. The degree of the third term is 5. So that's fine. So now we just need to find our GCF. So for 6, 18, and 24, what number goes into all three of them? The largest number. Yeah, 6, right? And for the A's, we're going to take the lowest exponent for A's, that would be 3, and the lowest exponents for the B's, that would be 2. So there's our GCF, 6a to the third b squared. Now we're going to divide each of them by 6a to the third b squared. The 6a to the third b squared, that will be written in front of the parentheses, and the answer to those division problems will be written inside the parentheses. All right, 6a to the third b squared in front of the parentheses, a squared b squared minus 3ab plus 4. All right, a couple more. These last two problems, they might not make sense right now, but later on they will. We're going to arrange in descending order if necessary, and then factor out a -1. Okay, so this problem, do we need to rearrange it? No, it's in order, right? The x comes before the constant. So we're just going to factor out a -1. That's our GCF. 1 is always a GCF, right? 1 is always a common factor to any term. Any 2 terms or any 3 terms, 1 is always a factor. So we're going to divide both of them by -1. That simply changes the signs, right? So the -1 is written in front of the parentheses, 7x minus 5 inside the parentheses. All right, 8y minus 3x. Is that in order? No. They have the same degree, but when we have different variables, we put them in alphabetical order. So the -3x should go first. Now we're going to factor out a -1. Again, that will change the signs, and the -1 is written in front of the parentheses. So that's it. I'll see you here for the next one.